Okay, so my project is an extremely basic visualization. So you can play a song and you get information back. You get told what note's being played, how long it's being played for, and like the frequency of the note. I had big problems getting Visual Basic to run both Maximilian, Open Frameworks, the libraries together. In the end, I just decided to do it in Maximilian in the command line because it was the only thing that seemed to work. So in my program, I've just got some basic variables, some oscillators. These here, this is just so I know what A4 is, what I know the notes are, the frequencies, because I'm not a musician. So yeah, I've got two basic melodies, two songs, one here and one here. They're both stored in arrays. The first array, note 1, this contains the first song, all the frequencies, the notes for each of the for every note. There's also a corresponding time that should be played in the second array. So note 1 has note time 1. This first note, 329, we played for 300 seconds, milliseconds, sorry. Yeah, and the same for the second one. This is a different song with different times and notes. So you can press X or Z while the program's running, and it changes between the two songs. Let's have a look. This part here, we're just checking. This is incrementing the note, so each note gets incremented. We play the first one and the second one, and when we reach the end of the array, we're just resetting it so the songs will play over and over again. They'll just keep repeating. And this here is getting the current time, checking if it's the same or equal to the start time, and added by the note time, which are these ones here. And if that's true, then it knows it's played it for long enough. So what we got here is these nested loops, these two nested loops. This is the core of the program. This is how the visualization happens. For every note in each song, we check what that note is. If it's 440, then we print out A4, and we do that the amount of times, which is equal to the frequency times 0.02. So if the note was 440, I'd expect to see 8 or 8.8 A4s. It's 8 in this case because I didn't round, so it just gets rounded down. So you've got 8 A4s, and then it prints them out. It prints out 8 A4s, the number of times, which is equal to the time that note should be played, times 0.01, which I believe is 5. So we should have, for this particular note, we should have 8 A4s 5 times, and then it would go to the next note. Yeah, just have that again for this is a repeat of the code for the second song. What I've got here is I'm using a combination of a saw, a triangle, and a sine wave to produce the end result. Yeah, we're just splitting between the two, the left and the right side. I'll just show you the program running now. So what you can see is this is the first song. I'll just wait for it to finish. This is like a big gap between each note. This particular song doesn't have many gaps, but I'm just going to switch it to the second one. And then you start to see there are more long pauses in between each of the notes. And just in case you can't see, I'll zoom in. So you should be able to see so those are actual notes, A4s and F5s, see, and they're being played based on the frequency and the length of each note that should be played. And just switch back to the other one. Yeah, and that's pretty much it.